presentation on multi-tenancy. So what is multi-tenancy? I went up to Wikipedia to see what they had to say because they are the source of all knowledge. And they say that multi-tenancy is where a single instance of software serves multiple client organizations or tenants in order to provide agility, scalability, reduce capital expenses, and operational savings. Well, that seemed like a pretty good definition, except where would you find a single instance of software that can do all this? I think a more viable definition would be a single integrated infrastructure that serves multiple client organizations, tenants, in order to provide those above 4 items. I think that's probably a better definition. What does multi-tenancy mean? Well, it means a shared infrastructure for handling multiple clients. It means the ability to scale out when one or more tenants come online. It means the ability to scale down when tenants become less active. It means the ability to scale down further when tenants leave the tenancy. It means the ability to have dynamically scaling, elastic infrastructure, one that can change to suit your changing business needs. It's the holy grail of cloud computing. When we talk about multi-tenancy, there's really a number of different types of multi-tenancy, and I'm not going to get into database issues in this particular presentation. At the highest level of integration and sharing is a true multi-tenant. If you look at the image on the far right-hand side, you see you have 2 tenants. They're sharing applications, they're sharing databases, they're sharing operating systems, all running on a shared hardware platform. That's a little too much sharing for my peace of mind. At a slightly less intense level is the multi-app instance, where you have separate tenants running separate applications, accessing shared databases on a shared operating system on a shared hardware platform. That's important for many types of web applications and cloud services, but it's not what I'm interested in when I'm talking about multi-tenancy. Third is the multi-stack approach, where you have separate tenants, separate application instances, separate data, all in a shared operating system, shared hardware. And that's getting a little closer to workable, except I don't like sharing operating systems. I'd rather have a more complete approach to multi-tenancy. Finally, we get what is called the multi-VM approach, and that is separate tenants, separate application instances, separate databases, separate OSs, all running as separate instances on a shared hardware infrastructure. And that's the kind of tenancy that I think is of greatest interest to our customers, and that I think is of most interest in cloud computing environments. Now, some security considerations when we start talking about multi-tenancy, and of course, this can't pretend to be a complete discussion of security considerations and policies. I just want to highlight some issues for you to think about as you start planning your own multi-tenant environments, or as you start talking to vendors about using their multi-tenant environments. And I'm going to divide these into 4 areas. The first is isolation and containment, where tenants are sharing physical resources. You need to be able to isolate them appropriately. You can't run Coke and Pepsi's infrastructure all on the same cloud unless you really have them isolated. Second is identity and access management control, which asks the hoary-eyed question, who are you and why do they keep sending you here? Third is the issue of transparency. Where are my assets and what are you doing to them? Fourth are processes and procedures, because you could have the most secure infrastructure in the world, but the next day, dreaded Upgrade Tuesday comes along, you could be out of date and full of vulnerabilities. When we think about security, we should think about security, and particularly when we're talking about isolation and containment, that data can be in different states. One state is data in process. It's actually in memory, in processor, and it's vulnerable in that state. And you need to think about not just data that's in memory, but also what's going through processors and caches, and the NICs and the HBAs, etc. Fortunately, the hypervisor, in most instances, provides complete isolation of data in process, and so it's not something that you actively need to plan for. But it is something that maybe the security professionals need to give some deeper thought to. Second, you need to think about data in motion. And here you can't rely on the hypervisors taking care of it for you. And in data in motion, even within your cloud environment or your data center environment, you need to have appropriate network security policies, procedures in place to make sure the data isn't secure. And by that, I mean a well-considered system of VLANs and firewalls. I know many people are going to large, flat layer 2 networks. From a security perspective, that seems like a mistake, both because it's a single point of failure and because when you have a large flat layer 2 network, the highest level of security you can receive is the lowest level of security that any of the servers in that layer 2 network have. So if you want to have different layers of security, and if you want to isolate faults, and if you want to have better troubleshooting, you better have VLANs and firewalls in place, and you better have layer 3 segmentation in place. And that's not something that necessarily comes native within hypervisors. That's why you need virtual routers. You also need to think about secure communications when you're talking about data in motion, and by that, of course, we're talking about VPNs, and whether it's IPsec or SSL. When we're talking about data in motion and security, we need to think not only within the cloud, but also outside of the cloud, and that is, what is going to be the policies of tenant DMZ zones? How are you going to isolate them and isolate traffic from them to the internal processing network? What kind of site-to-site VPN solution do you have in place? Is it going to be static or dynamic? What is going to be the key management for that system? You need to think about how it is you're going to provide remote access, remote users and web users with secure access to your infrastructure. Finally, if we talk about data at rest, we need to think about how to secure the data that's being stored, whether it's network attached storage or storage area networks. Security policies and procedures and technology needs to be in place. If we start talking about identity issues, and that's that question I love to hear asked, who are you and why do they keep sending you here? Here you get the important questions of identification and of identity issues, and that is, who are you? Prove who you are and say who you are. Prove you are who you say you are. Authorization. Okay, I now know who you are. What is it that you're allowed to do? What is your role? And validation. How are you going to double check before executing? And that needs to be part of any identity management system, whether you're talking about cloud-based or non-cloud-based. And then we need to think about transparency. Where are my assets and who is doing what to them? You need to, of course, have accountability in place. All actions need to be securely recorded, both actions by clients and by those managing the clients. You need to have a chargeability system in place, the ability to pay to play. And you need to have a well-considered system of SLAs so that you know what level of availability and scalability and performance your customers are expecting of you and that your management is expecting of you. So those are some of the security considerations. The more interesting part of this presentation is looking at some of the multi-tenant sample use cases that we've encountered. I shouldn't say sample use cases. What I'm going to talk about are two current customers who've developed what we think are very innovative and exciting ways to provide multi-tenancy in the cloud. They're both forms of cloud service providers taking very different approaches to multi-tenancy, and we'll take a look at from the actual diagrams they provided us. All names have been removed to protect the innocent. The first is a large client cloud service provider in the APAC region. We love them because they're an all Brocade shop. So they've got Brocade MLX at the top of the rack, Brocade VDX providing Ethernet fabric. They've got VDX layers below that, a number of servers, storage tier, which is also all Brocade. But it's not telling you very much about what's actually going on in this cloud service provider. So instead of looking at the physical architecture, let's take a look at their logical architecture. And here what they've done is they've taken these racks, okay, and they've turned them into large virtual environments divided up into user domains. So customer A, customer B, customer C, each one is a separate tenant. Each one they're providing different types of services, and the customers were responsible for, installing and deploying and designing what it is that's going to be running within these instances. So customer A has a Viata firewall front-ending them from the outside world, and also a Viata firewall at the back end, which leads out to the management network and the backup networks. within user domain A, the customer A, they have what they call the application layer. And in the application layer, they have, well, applications. In this case, inventory management, human resource applications, user self-service, like an Oracle self-service application. Again, using firewall to provide nested virtual machines within virtual machines. Okay, within that inventory environment, within that application environment, they have different levels of production, and that is a quality assurance environment and a production environment, and never the twain so meet. That allows them to have a test and dev environment. Once it's ready to go, then they can move it over into production. And finally, within the production environment and within all of these, they have security zones. So they might have an internal security zone, a DMZ zone, based on who's allowed and how much forward-facing outside people allowed access parts of this application. So we see quite a sophisticated environment in place. And what's interesting about it is if we go back to that physical infrastructure, we don't see a lot of networking gear. Don't see a lot of routers and firewalls. But if we go back to this screen, we see, I'm going to guess 24 different firewalls and routers in place. What they're doing is they're actually providing all of those routers and firewalls in software so that when a customer comes in, they can automatically supply them front-end and back-end firewalls and routers, VPN technology, all as part of a software instance. They can just click a button and roll it out and deploy it. If that customer leaves, they can turn it off again. It's that ability to scale out and scale down on demand. The second situation is a little bit different. They're not a classic cloud service provider. Rather, this was a government contract where the customer wanted to have the ability to roll out new data centers on demand. And they started by defining a standardized data center that they thought would be appropriate for all the situations they were going to encounter. So they came up with a standard multi-tiered data center design that I'm sure you've seen before, encountered in school. They had an application tier with production, development, and QA servers, all of which were virtualized, with all the appropriate VLANing in place. They had a virtual web tier, again with VLANs for development, QA, and production. A database tier, and this is looking like every other database, generic database presentation you've seen before. They of course included a part of that backup and management networks, again with everything virtualized as much as possible. So they now have what's essentially a software data center except all the networking components. And they took that to the next step and replaced all of what in this case was Cisco routers and firewalls with Viata-based routers and firewalls. Now you have a true software-defined data center. Now it's not employing any kind of experimental overlay technology. This isn't really a truly SDN-based environment. This is using tried and true technology with protocols that you know and love, like BGP and OSPF and VPN technology of IPsec and SSL. But they did it all in virtual environments. And what that allowed them to do was template the entire 30,000-foot data center into a VM, with VMs running within the VMs. And every time they needed to deploy another data center, in this case I believe it was an emergency response application, so there's another emergency, they wanted to have an isolated data center just for that situation, they could click and roll out another one, and with minimal amount of customization, they'd be up and running. And there were a lot of advantages to this approach because they had a standard template in place. All the servers had the same IP addresses. Troubleshooting and customization was straightforward. Their developers knew just what servers are in place and what versions they were updated to, where to find them, how they were communicating to each other, what were the ACLs and firewall and security policies, all standardized. And that made troubleshooting, management, deployment, support all much, much easier. And this is an exciting in-production environment running today. In this case, they had it running on a great big rack server, but there's other physical media that you could have used for this. To provide high assurance in this environment, they used Layer 2 cloud bridging. And that allowed them to identify if a particular data center went down and to roll over into another data center. And that also provide application mobility and scaling. Now, I'm not so sure if application mobility at a distance is really such a great idea, but for high assurance purposes, if you're talking about what they're trying to achieve, it seemed like a very viable approach. So those are two examples of multi-tenancy at cloud service providers. I think they're very interesting, forward-looking approaches, ways of solving the problem with current technology and with tried and true technology, and technology that by and large you're probably familiar with. So who are we? Viata is a Brocade company. We were acquired by Brocade just about 4 months ago. We're a Silicon Valley company that's been selling solutions since 2006. We're based on the idea that the future of networking is in software. We provide networking software that does routing, firewall, and VPN. We're based on open architectures. In fact, we're an open source solution. We're not supporting OpenStack yet, despite what it says there, but that's something that we'd love to be talking about in the future. And we're based on open standards. We're supporting the networking standards that you know how to use, and that all IP networks are running on. Our architecture is pretty straightforward. What we did essentially is we assembled about 400 different open source packages for Linux environments. We provided a common data model on top of those, so that we have a common command line interface, common set of RESTful APIs, a common GUI, all for managing all of these different networking packages. Now, you could do the same thing. You can go out and you can find Quagga and you can find OpenVPN and you can put together your own Linux-based networking solution, but we've done it for you. And more important than just doing it for you, we've applied a common data model to all of them so that you can manage it all through one interface, one set of APIs, and one GUI. What do? We do what you'd expect. We are an advanced, very feature-robust dynamic routing solution supporting IPv4, v6, static and dynamic routing, policy-based routing, OSPF, RIP, BGP. We have extensive security capabilities, including a stateful firewall and NAT. We have the ability to do URL filtering through a technology called ViataGuard. We have a number of different VPN technologies in place, including IPsec and SSL-based VPNs, route-based layer 2 cloud bridging, and coming in the next release, you hear it here first, folks, we have dynamic multipath routing coming in. System management is through the command line interface or through the RESTful APIs or through the GUI. We provide extensive IP services, high availability platforms, high availability options, and we are platform agnostic. We're a version of Linux. You can go and install us on your laptop. You can install us on an x86 server. You can install us in any of the major hypervisors. We'll run equally well in all of those environments. And with that, we conclude the presentation today. And this seems like an excellent time to take some questions and see how my audience is doing. So give me one moment while I open up the question panel. In the audience panel, you can click on the hand on the upper right-hand side if you have any questions. And I see, or you can type in the question panel and I will see those questions. And I see the first question has come in, and someone is asking, what is the difference between the open source and the open source? I think they meant what is the difference in the open source and the paid version of Viata. We are an open source company, and you can download the open source version and you get a very functional product that you can use for free. However, what you don't get is the graphic user interface. You don't get the RESTful APIs. And in the next version, you're not going to get a couple of key new technologies that are coming out, such as dynamic multi-point VPN and multicast technologies. There are also some differences in authentication that's not available to the open source version. So if you go to viata.com and click on the products icon, you'll find a tab that lists the differences between free and enterprise, and that will go through those features in more detail. The next question is, are we an SDN solution? Are we an SDN solution? We're a step on the path to SDN. Okay, we're not supporting OpenFlow today. We're not supporting OpenStack. There isn't a controller that you can use for controlling Viata routers. However, we do provide the ability to take those islands of SDN that you may be playing with in your lab and to tie them into your legacy networks using, common open standards like BGP. We also provide you secure remote access into those islands of SDN. We provide many of the benefits of software-defined networking in that we're software. And when you're looking for a solution that you can deploy on demand, that you can orchestrate with a simple set of APIs, it's a software-based solution. It's a lot easier to turn us off and turn us down, turn us up or turn us down in software than to order a new router, get approval for it, get the box, open it up, crawl into the racks, get down and figure out the power supplies and the wiring. Doing it in software saves you a lot of time. Next question, how do we compare against Cisco? Well, I guess that depends on which Cisco product you're talking about. Cisco recently launched a solution called their Cloud Services Router, CSR 1000V. It's a feature-rich solution, as you would expect from Cisco, and it comes with all of Cisco's branding and marketing behind it. It certainly is a technology that I'm sure you've all been trained on how to use. However, Network World took a look at the router just a few weeks ago and found that its performance was abysmal. And in fact, they tested Viata on the exact same platform, and they found that where the Cisco router required 4 physical cores and virtually all of the memory in their box, and they had a high-end system, and it still provided only, I think it was 50 Mbps of throughput, the Viata router required a fraction of those resources, just 1 physical core, and provided over 500 Mbps. And there's a lot that could have been done for optimizing us in that environment. So I'm sure Cisco will get there. They got a lot of good engineers, but the CSR product that's available today has significant performance issues, and I think you should take that into account when you consider what solution to go for. All right, I don't see any of the questions coming up. There's still time. If you have any questions, click on your hand icon or type it into the question bar. Well, I think I've answered everything. I don't see any other questions. And so with that said in place, I think it is time to end this presentation. I appreciate everyone coming today. I urge you all, we just posted another webinar being done by David Myers, who's Brocade's chief scientist, and he's giving a webinar on the end of March on the future of networking. He's a dynamic speaker with a lot of very interesting thoughts on the direction that networking is going to. In fact, I'm going downstairs to listen to him give a talk right now as soon as I'm done here. That's why I'm talking so fast. Go back to viata.com, click on the Learn, go to our list of webinars, sign up for David's webinar. It's going to be a good one. Thank you, everyone, for joining us today. Hope to see you again next week on our webinar on cloud bridging. Thank you, everyone. And with that, I'm going to end today's presentation.